Hi everyone, this is Mr. Enzler. I'm sorry I can't be there today. My wife's grandfather died, and so we are at the funeral. So that's why I'm not at school today. I do plan to be at school tomorrow on Tuesday. Okay, well, when we left off before Thanksgiving, we had done lessons 6.1 and 6.2, and then we went over our tests. And everyone made corrections on their tests. So if you are wanting to retest, just make sure you talk to me about that when I come back to school tomorrow. So, if you please could have your packet out, we are going to go over lesson 6.3, which is all about similar polygons. All right, and you can see I have these terms defined for you. So take a moment now to read through those. Read through these terms right here. Okay, the main idea is similar polygons. These are two shapes that they're the same proportional shape, they have the same angles, congruent angles, but different side lengths. So these two triangles that you see, these are similar polygons. They're the same shape. If you measured the angles, they would match up. All three angles would be congruent from one to the other, but they're different sizes. Obviously the second one is larger, and that's okay. They can still be similar. So, similar shapes have a scale factor. They have a ratio between corresponding sides. The scale factor tells how much larger or smaller one figure is with the other. So, let's say this big one is twice as big as the small one. Well, the scale factor would either be 2 to 1, or if you were going the other way, 1 to 2. The statement of proportionality, this is just where you write the ratios of corresponding sides. We'll do that down below. And then lastly, the similarity statement. This is where we can say two triangles are similar. So for instance, let me zoom in here. I could say that triangle ABC is similar to, this is the similar symbol, triangle FDE. And just like with congruent triangles, the order you put these in matters. When I said ABC and FDE, that would mean that we have some angles that match up, like angle A and angle F. Since I put those first, those angles must be congruent. Angles B and D would be congruent. Those are corresponding angles. And angles C and E would be congruent also. So the order you write them in matters. Alright, so let's follow the directions here in example 1. They're telling us that these two triangles are similar, and the order matters. So list all pairs of congruent angles. Well, let's start with the fact that angle R is first, and so is angle X. So angle R is congruent to angle X. And I can mark that on my diagram. Angle R and angle X are congruent. What else would be congruent? Well, S and Y are next in line, so angle S is congruent to angle Y. And lastly, both T and Z are last in order, so we know those go together. Angle T is congruent to angle Z. So since these two triangles are similar, all three angles of one triangle are congruent to all three angles of the other. Doesn't mean that all three angles are the same. It just means they're congruent between the two triangles. Now, B says check that the ratios of corresponding side lengths are equal. If these two triangles are similar, and we know they are, then the side lengths, when we compare them, should form the same ratio. So here's what I mean by that. TR is 25 and XZ is 15. If we compare those, 25 to 15 might look like this. And if you simplify that, what do you get? Well, we can divide the top by 5 and get 5. And if we divide 15 by 5, we get 3. So 5/3. That doesn't really tell us anything except that the one triangle is a ratio of 5 to the small triangle of 3. What we want to know is, are all the side relationships going to equal 5/3? So check the ratios of corresponding side lengths are equal. We want all of them to equal 5/3. So let's do 30 and 18. 30 to 18, let's see here. What can we divide both of those by? We can divide them both by 6. 30 divided by 6 is 5. 18 divided by 6 is 3. Hey, look at that. They're the same. And lastly, 20 and 12. Let's see here. What can we divide both of these by? 20 divides by 4 to get 5. If you divide 12 divided by 4, you get 3. So this works. All three side relationships have the same ratio. They're all a ratio of 5 to 3. So write the ratios of the corresponding side lengths in a statement of proportionality, letter C. What we're going to do here is we're going to write that side TR compared with ZX, that's my first two sides that I compared, the 25 and the 15, that the relationship between those two sides is the same as the relationship between TS and ZY, and that is the same as the relationship between RS and XY. It's kind of what we just did in part B, but here in part C, this is what we mean by a statement of proportionality. We're saying that the sides are proportional. So that's a statement of proportionality. All right, lastly for this one, part D, find the scale factor of ZXY to TRS. So we need to go in that order, the scale factor, ZXY to TRS. So compare any two of the side lengths. How about 25 and 15? And so if we compare the side lengths, we have 15 to 25. If we reduce that, we know we can divide them both by 5. We get 3 to 5. So the scale factor is 3 to 5, or you could write that as a fraction, 3/5. Now, why is there a difference between that 3/5 and up here 5/3? Well, in part B, you could divide them in either order that you wanted to. I just did 25 divided by 15. We got 5/3, and then I kept it in that order for the other ones. But in part D, it specifically says compare ZXY to TRS. So I need to start with triangle ZXY and put TRS second. So the scale factor is 3 to 5. For every 3 that is part of the small triangle, the big triangle is 5. All right, I hope a lot of that made sense. Let's move on to number 2. Determine whether the polygons are similar. If they are, write a similarity statement and find the scale factor. Okay, so let's see if they are similar. First thing, let's compare their angles. Are all of the angle pairs matching up? I can see G and Y are congruent. F and Z are congruent. J and W are both right angles, they're congruent. And angles H and X are congruent. So by the angles, these are all congruent. But to be similar, they have to have all the same angles, and the sides have to all be proportionate. So let's check that. And I'm just going to go in the same order we did last time. I'm going to go 20 over 25. I can see those sides should correspond. They're not congruent to each other, but they correspond with each other. And then let's simplify that ratio of 20 to 25. That simplifies to 4/5. So what we want to know is, do all of the side relationships simplify to 4/5? Well, let's see. You got to try all of them and you got to show it. 16 to 20. Let's see, those both divide by 4, and yeah, we get 4/5. How about 12 to 15? 12 to 15. Those both divide by 3. 12 divided by 3 is 4. 15 divided by 3 is 5. So 4/5. Okay, it's looking good. Last set, 24 and 30. Those can both divide by 6. 24 divided by 6 is 4. 30 divided by 6 is 5. So we can say yes. And we're going to write a similarity statement. That's what it says to do. Write a similarity statement. So these aren't triangles. These are quadrilaterals. We don't really have a symbol for that. So how about I just say GFJH is similar to, now we got to go in the same order for the second one, YZWX. So yes, they are similar. And the reason why is because all of the angles matched and all of the sides were proportionate. They weren't congruent, but they all boiled down to the same ratio. All right, last question. Find the scale factor of ZYXW to FGHJ. So we have to go in that order. We have to start with the Z one and go to the F one. So we've already figured out that the ratio from the small to the large is 4 to 5. So if they want us to go in a different order, that's fine. The scale factor would then be 5 to 4. Or you could write it as a fraction. If you wrote it as a fraction, it would be 5 over 4. So that is the scale factor. So again, when you check to see if the sides are proportionate, you can go in whatever order you want as long as you go in the same order for each of them. When you do the scale factor, you have to go in the order that it says. So it says the Z one first and then the F one. So that's the order you have to go in. All right, let's turn the page. Here we have example number 3. It says, determine whether the polygons are similar. So again, we have to check to see if they are similar or not. If they are, write a similarity statement and find the scale factor. Okay, so do we know all of the angles match up? Let's see here. C and T, D and U, E and V. All right, that's a good sign. Let's check to make sure the sides match up. So let's see here. CD is what I'm going to start with. And CD goes with what other side? Well, CD is between the 1 congruence angle and the 2 congruence angle. So we need to find the one in the other triangle that's like that. And that would be UT. And so if we compare CD and UT, we have 10 over 8. Reduce that, we get 5/4. So we want to check, do they all have that same relationship, 5 to 4? Let's do CE next. I know CE is 12. What side does CE go with? Let's see here. CE is between the 1 congruence marking and the 3 congruence marking. So CE is going to go with VT. And VT we know is 9.6. All right, I might have to get out my calculator for this one. If I type into my calculator 12 divided by 9.6, it tells me that that equals 1.25. So the question is, are 5/4 and 1.25 the same? There's a number of ways to figure that out. Maybe the easiest way is to just divide 5 divided by 4 up here at top. And yeah, that is also 1.25. So you could express this either as a fraction or as a decimal. All right, we got to check the remaining ones. And the ones that I haven't checked are DE, which is 5, and what else? VU, which is 4. Oh, well that's nice. It's already 5/4. We don't really have to reduce it. So yes, we can say yes, these shapes, these triangles are similar. So let's write a triangle similarity statement. Let's say triangle. You can pick whatever order you want for the first triangle. I'm just going to do triangle CDE is similar to triangle, now we got to put this in the right order. C goes with angle T. Angle D is congruent to angle U, and angle E is congruent to angle V. So there would be our similarity statement. And what else do we have to do? Find the scale factor. Now, in this case, it didn't say what order we're supposed to go in, so let's just go in the order we were already going in. We kind of already realized it's 5 to 4. So scale factor is 5 to 4. The order 5 to 4, that's written from big triangle to small triangle. For every 5 units there is in the big triangle, there's going to be 4 in the small triangle. That's their proportional relationship. All right, let's take a look at the next one, number 4. In this diagram, all right, they're telling us these triangles are similar. Find the value of x. So we need to set up a proportion to find x. You notice we have 2 complete relationships that we know. If you compare 9 and 12, those correspond, so that's like a complete pair. So are 12 and 16. It would not do much good to set them up as to each other. Although they are, it just wouldn't help you solve the problem. If you did 9 over 12 equals 12 over 16, that's true, but it's not really going to get us anywhere. So we want to set one of those, pick whichever one you want, either 9 over 12 or 12 over 16, and we want to set that equal to x over 20. So I'll just do 9 over 12. 9 over 12 equals x over 20. I know the x and the 20 are corresponding sides. They're not equal to each other. We can clearly see the 20 is bigger than this x. But they are proportionate. So we set up this proportion, and now we just solve it. This is what we were doing the last couple days of class. So we're going to cross multiply. 12 times x equals 9 times 20. 9 times 20 is 180. And then divide both sides by 12. And we realize that x equals, let me just type this into my calculator here, 180 divided by 12 is 15. So x is 15, and that's what we needed to do. Okay, here's another one, number 5. In the diagram, these 2 quadrilaterals are similar, and we want to know what is the scale factor and then what is x. And the scale factor they are giving to us in a certain order. They're saying QRST to ABCD. So that's how you need to set up your ratio. So let's just take one pair of sides that correspond. How about this side 10 and this side 5? Those are corresponding. So we have to go in order, do the Q1 first. So this is going to be 5 over 10. It has to be in that order. All right. If it just says what's the scale factor and it doesn't give you an order, well then you can put it in either order. But because it says from QRST to ABCD, you have to put it in that order. And then always reduce it. So the scale factor is 1/2. So just a slight tweak on how to solve this to figure out x. Use the scale factor. I mean, if we have to find the scale factor anyway, let's put it to use. And so our scale factor is 1 to 2. And so that's the small quadrilateral to the big quadrilateral. So then 4 to x is going to go on this side. And we want to go in that order from the small one to the large one. And now let's just cross multiply and solve. So 1 times x is x. 2 times 4 is 8. And we get our answer. All right. Number 6. A rectangular playground has a length of 25 meters and a width of 15 meters. I don't know about you, but I feel like drawing that as a diagram. So there's my best rectangle. Rectangles have 4 right angles. And the length is 25. The width is 15. Okay. You are constructing a new playground with a similar shape. And when we say similar, we mean mathematically similar. But it's only 10 meters in length. So this one's going to be smaller. Try to draw a smaller one. This one's going to be 10. Find the scale factor of the new playground to the original playground. So this is the new one. This is the original. So we have to go in that order, from new to original. So the scale factor would be 10 to 25. And we want to reduce that. They both divide by 5, so 2/5. That's the scale factor. And then it says find the perimeter of both the new and the original playground. Well, the original one, I can find the perimeter to that. I just do 2 times the length plus 2 times the width. So 2 times 25 plus 2 times 15. That's 50 and 30. So 80, and let's label this 80 meters is the perimeter of the original one. What's the perimeter of the new one? Well, I don't really know. Not yet, at least, because all I know is one side is 10. I don't know what the other side is. So let's call the other side x, or w maybe for width, and set up a proportion to solve this. So I'm going to say 25 over 10. Oh, actually, instead of doing that, let's use the scale factor. Let's use 2 over 5. It's already reduced. That'll save us a little bit of time. So 2 over 5, and that's going to equal w over 15, or x over 15. Cross multiply, you get 30 and 5w. Divide, and we realize the width is 6. So if we know the width is 6, now we can find the perimeter. Perimeter is 2 times 10 plus 2 times 6. So that's 20 and 12. The perimeter is 32 meters. I wonder, what's the relationship between these two perimeters? What if I do 32 over 80? What does that equal if I simplify that? Let's see here. What can they both divide by? They can both divide by 8. We'd get 4 and 10. And then those can both split in half. Hey, look at that. The scale factor of their perimeters is the same as the scale factor of one side to the other. That's something that could come in handy, useful to know. Alright, so you have the rest of class time to work on the homework assignment. Why don't you get that homework out? And let's just preview this a little bit. The first question is just kind of an understanding question. If two polygons are similar, are they also congruent? Must they also be congruent? What if they're congruent? Must they also be similar? So answer both questions and explain like it says. Number 2, you're listing the pairs of congruent angles. Then you're writing ratios of the sides with a statement of proportionality. You already know that they are similar. In number 3, you have to determine yes or no if the polygons are similar. So in A, look at these triangles. Are they similar triangles? Yes or no? If they are, write a similarity statement. Make sure you do that part. That's where you say triangle blank 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 is similar to triangle blank blank blank. If they're similar, you have to write a similarity statement. Also, find the scale factor. You can do it in whatever order you want. It doesn't have a particular order listed, but compare the sides and reduce. You kind of have to do that anyway when you determine whether the polygons are similar. That's going to be part of it. If they are similar, you'll already know what the scale factor is. All right, and the last two, number 4, are the polygons always, sometimes, or never similar? So think about those. It's kind of a conceptual question. Sometimes, always, or never. And then the last one, two triangles are similar. If the perimeter of the smaller triangle is 64 and the perimeter of the larger is 192, what's the scale factor? And it might help to draw a picture there, maybe not. But do your best to solve these problems. Work together, but make sure you are working on these. All right, I will see you tomorrow. Be a good class, work hard, do what you're supposed to do, and I hope you have a good start to your week.